Let's talk about determining if the columns of a matrix are linearly independent. For example, determine if the columns of the matrix 8, 6, 7, 5, 3, 0, 9, 0, 0 are linearly independent. Let's review the definition of linear independence. A set of vectors is said to be linearly dependent if you can express one of the vectors as a linear combination of the others. If no vector can be written as a linear combination of the others, we say the set is linearly independent. Here's the alternate definition of linear dependence and linear independence, and this is actually the one we'll use. A non-empty set of vectors S equals v1, v2, v sub n is linearly dependent if c1 v1 plus c2 v2 plus plus c sub n v sub n equals 0 has a non-trivial solution. In other words, has a solution where not all the c sub I are 0. Such a set is linearly independent if the only solution to c1 v1 plus c2 v2 plus c sub n v sub n equals 0 is the trivial solution, c1 equals 0, c2 equals 0, c sub n equals 0. In other words, it's linearly independent if the only way this is possible is if all the c sub I are 0. Okay, so let's determine if the columns of the matrix are linearly independent. Well, let's look at these columns. 8, 5, 9, 6, 3, 0, 7, 0, 0. Let's call those column vectors v1, v2, and v3. We're going to look for solutions for c1, v1 plus c2, v2 plus c3, v3 equals 0. So in other words, we're looking for solutions to that. Are there non-trivial solutions, or are the only solutions c1 equals 0, c2 equals 0, c3 equals 0? Okay, so here's our equation. We can write this as a matrix equation, ax equals 0. This is our matrix A that we were talking about earlier. We're going to call this our vector x. Put a little thing on it to make it look like a vector, and this is the 0 vector. So we're going to write this as a matrix equation, ax equals 0. Here's another way we could write that. If you multiplied this out, you'd end up with 8c1 plus 6c2 plus 7c3 equals 0, 5c1 plus 3c2 plus 0c3 equals 0, 9c1 plus 0c2 plus 0c3 equals 0. Or in other words, if you represent that system of equations as a matrix, as an augmented matrix, this is going to be your augmented matrix. Okay, we know how to solve a system of equations like that. We get it in reduced row echelon form. And this is what we end up with. Notice what our solution is. C1 equals 0, C2 equals 0, C3 equals 0. Okay? Remember that a set is linearly independent if the only solution to this equation is the trivial solution. C1 equals 0, C2 equals 0, etc. And that's exactly what we had. The only solution to this matrix equation is the trivial solution. C1 equals 0, C2 equals 0, C3 equals 0. And since that's the only solution, the trivial solution, we can say, therefore, the columns of the matrix 8, 6, 7, 5, 3, 0, 9, 0, 0 are linearly independent.